Now that we've covered the basics of indefinite integration, let's do some examples of indefinite and definite integration for vector valued functions. The first is we want to find some indefinite integrals here. So remember that since these are individual component functions, we simply need to find the antiderivatives of each one. So the antiderivative of 4t cubed is t to the fourth. The antiderivative of 6t is 3t squared. And the antiderivative of 4 square root of t is 8/3 t to the 3/2. Right? That's like t to the half, add 1, get 3/2, divide by the power, etc. So that's our parent antiderivative, and do not forget to add that constant vector. Similarly, we go to this one, natural log of t. Now, natural log of t is not one that you probably have off the top of your head. So we would have to take an integration by parts if we wanted to normally do natural log of t. But the eventual answer would be t natural log of t minus t I. That's the standard, or that's the parent function, or the parent derivative, or antiderivative of that. So 1 over t, recall that antiderives to natural log of t. And that's just k, so that's just a 1, so the antiderivative of 1 is t. And we have our constant. So those are our two answers there. Let's do the same idea, but for definite integrals. Now remember, we just need to find the antiderivatives and evaluate at the limits. So the antiderivative of t is 1/2 t squared I. The antiderivative of t cubed is 1/4 t cubed, or t to the fourth j. And the antiderivative of t to the 1/3 is 3/4 t to the 4/3. K. And we evaluate that from -1 to 1. So for each of these, we plug in its value at 1. And we subtract the value at -1. All right, forgot to put a negative there. And that's I, j, and k. So, looking at this, well, 1 squared and -1 squared are the same number. So that's going to go to 0. 1 to the 4th and -1 to the 4th are the same number. It's going to go to 0. And 1 to the 4/3 and -1 to the 4/3 power are also the same number. So we get that this is 0. So let's talk about that, why I could have known that from the beginning for the moment. Now, all three of these functions are odd functions. So if you remember what an odd function means, definitionally it means when you plug in a negative number for t in this case, you get the negative version of plugging in a positive number. For example, sine of x is an odd function, but cosine of x is an even function. And the way you usually see that is that it's like it's flipped over the line y equals -x. Or it's folded over y. It's either y equals x or y equals -x graphically. But the idea is when it crosses through the origin, positive values and negative values look like reflections of one another. So anyway, why am I saying this? Well, t cubed, and cube root of t are all odd functions, and on a symmetric interval, odd functions are always, the integral of an odd function over symmetric interval is always 0. So I could have looked at this and said, that's odd, that's odd, that's odd, that's a symmetric interval, 0. So don't work harder than you have to, is really the point. Now let's take a look at this one. This one's going to be a little more complicated, but not terribly so. So the antiderivative here is 1/2 t squared I. Antiderivative here is e to the t. And antiderivative here, again, this is another integration by parts. You may not remember this. T e to the t minus e to the t. Now you can take the derivative and find that that does derive back to this. So we can rewrite this if we wanted to say 1/2 t squared I plus e to the t j plus e to the t minus t e to the t. Okay. That might be easier, it's whatever. All right, so let's take this from 0 to 2. So then we're going to have 1/2 2 squared minus 1/2 0 squared I plus e squared minus e 0 j plus e squared minus 2e squared minus e to the 0 minus 0e to the 0. Okay. Well, that's 4 divided by 2 is 2. So we have 2i. E to the 0 is 1. So this is e squared minus 1j. So that's e squared minus 2e squared. So that's negative e squared here. And 0 times anything is 0. E to the 0 is 1. So that's minus e squared plus 1, right? Because minus e squared minus 1. Okay. And that's your answer for this one. And that's some examples of definite and indefinite integrals for vector valued functions.